Hello guys, let's see one problem, a basic problem from single phase AC circuit. Here it is. An RL series AC circuit has 15 volt across the resistor and 20 volt across the inductor, the supply voltages. So the expected diagram is you have a resistor and an inductor in series connected to an AC supply, and given that it is 15 volt across the resistor and the 20 volt is appeared across the inductor. So we have to find the net voltage. So unlike in DC circuit, it is not the case that you add both of the voltages so that you get the supply voltage. But here you have to go for vector addition. That is, as seen in the voltage triangle described in the last video, you have VR over here as the reference or the horizontal line as VR, and since it is an inductor, we should have a voltage which is perpendicular or pointing upwards and starting from the head end of the VR. Okay, so this will be your VL, and which is equal to 20 volt, and this is your 15 volt voltage across the resistor. So the net voltage will be the vector addition of both of these, which is root of VR square plus VL square. So that comes about root of 15 square plus 20 square, or it is 225 plus 400, that is 625, which will give you 25 volt. So the supply voltage, the answer over here is 25 volt is your answer. Now let's have an extended version of this question. Here it is. In an AC series RLC circuit, the voltage across R and L is given, voltage across L and C is given, and voltage across the whole R, L and C is given. You have to find the voltage exclusively for C. So it is a series connection of resistor, inductor and the capacitor. So it is given that C voltage across R and L is 20. This comes about 20 volt, and voltage across L and C is 9 volt, and then the whole across the whole components it is 15 volt. Totally it is 15 volt. So we have to just get the value of the voltage which is across the capacitor. Okay, so moving again with the vector or the phasor diagram. See, this is VR and VL is always pointing upwards from VR, so it is VL. Now across R and L it is 20 volt. So the vector summation across R and L it is 20 volt. Okay, next is L and C, it is 9 volt. So usually always L, mostly, not always, mostly L is always greater than C, or X. So mostly XL is greater than XC or VL is greater than VC. Okay, and VC, you know, the vector or the phasor is drawn pointing downwards. So this is your VC. So the difference VL minus VC, we are subtracting VC from VL. So the result will be pointing upwards. So VL minus VC will be like this. And this voltage, the net voltage across L and C is about 9 volt. Okay. Now the voltage across RLC is 15 volt. So here is your VR, the voltage across the resistor, and this red color phasor is the voltage across L and C, the net voltage across L and C. So the resultant or the net voltage across R, L and C will be the vector addition of this blue horizontal line VR and this red VL minus VC. Okay, so this is the vector addition of VR plus VL minus VC, and that comes about 15 volt. Let me draw this triangle separately. So here is a triangle which has VR over here, and this is the 9 volt, and the net voltage across R, L and C is about 15 volt. So what will be VR? VR will be root of 15 square minus 9 square, the simple Pythagoras theorem. So it is 225 minus 81, which comes about 12 volt. So VR is 12 volt. Now let me separate this blue triangle as such, that is VL, this one, the first drawn triangle which is VL and VR. Now the value is ready for VR, that is 12 volt, and the net voltage is 20 volt. So what will be VL then? It is root of 20 square minus 12 square, which is about root 256, that is 16 volt. So VL is also ready now. Okay, now let us substitute, just give the values, every values over this red equation, that is VL minus VC is equal to 9 volt, VL is equal to 16 minus VC, which needs to be found out, is equal to 9 volt. Now 16 minus 9 is equal to VC, or VC value is 7 volts. So this is the voltage across the capacitor. So that is the question. Once you get to know how to draw the phases of this voltage values, then you will be very easy to deal with such kind of questions. Stay tuned for more questions on this topic. Thank you.